Good day everyone. Today I'm going to present to you our project title. Our project title is Trajectory of an Object in Projectile Motion, reference to the angle. For your info, we are from Group 1. Our group consists of 5 members. Firstly is me, Abishai. Second is AIZUDDIN. Third is ASLAM Khan. Fourth is IZZUL NISA. And lastly is AZIM ISKANDAR.
According to BCIT Physics 0312 textbook, projectile motion is the motion of an object thrown or projected into the air, subjected to only the acceleration of gravity. This study of motion is also known as ballistic motion, which is commonly found in space exploration, missile launching, and many more. The object which is launched is called a projectile, which moves in a curved path, which is called a trajectory.
Next, we go to the objective of our assignment. The objective is to study the ties of the initial velocity of an object in projectile motion linked to the angle of its trajectory.
So for material and apparatus, we use weight, F-clamp, protector, nerve gun, meter ruler and long measuring tape. This procedure, we assemble and arrange the apparatus according to figure 1 and we use suitable method to set the angle of apparatus, specifically setting the angle 0 to 15 degrees. The gun was fired and the bullet was discharged at a selected height, which is H. The location for the bullet, where the bullet hit, was determined using a meter ruler, and we record it. We record the result. For the H, which is height, was kept constant, and the angle theta was increased by 15 degree in different stage. The process of setting the angle was repeated for each stage. This position of the impact mark, which is X, were measured and recorded for each different stage.
Good day everyone. Today I'm going to present to you the results of our experiment. As you can see from the table, there's a 15-degree increment for each angle. For the first angle, 15 degrees, we got an average range 11.4 meters, and the second one is 30 degrees, where we got 19.5 meters of range. And next is 45 degrees, where we got the range of 22.9, and for the 60-degree angle, we got an average range 17.7 meters, and lastly is 75 degrees, where we got 9.9 meters in range. From the first equation, range, which is also known as R equals to cos theta times time, when we rearrange the equation, we can get the time of flight, which is also T equals to R over U cos theta. And also using the vertical distance, which is S equals to H plus U sine theta times by time minus by 1/2 of gravity squared of time. When we substitute the second equation, which is T equals to R cos theta, we get an equation for the initial velocity, which is equals to U equals to square root of R square over cos square theta times by gravity over 2h plus by range tangent theta. From there, we can get an average velocity. From the equation we discussed previously, we can get a similar equation, which is y equals to mx plus c. From there, we can plot a graph. As you can see, the y-axis is actually h plus r tangent theta, and the x-axis is 1 over 2 g r over cos theta and squared. From the linear graph plotted from the previous slide, we can get a gradient of 0.0051, where it is also equals to 1 over u square. From there, we can directly get the initial velocity where u is equals to 1 over 0.0051 square root. We get the answer of 14 meter per second. As you can see, the experimental value is less than the theoretical value, where the percentage error is equals to 1.55%.
Next, we go to the discussion. First, the reading was taken multiplied times and the best three from the set of data collected were chosen for each angle to obtain a more accurate result. The experiment is carried out on an even and flat surface to ensure a more accurate reading. Number 2, as the angle of trajectory increases, the maximum height of the bullet increases and hence the air resistance increases due to greater exposure of wind. To overcome this issue, the experiment should be carried out indoors where the ceiling is high enough for the experiment. Number 3, to prevent the stand that holds the toy gun from moving, weights should be added in order to further secure the stand that holds the toy gun. This ensures the bullet that is fired from the toy gun is not affected due to the swing motion of the gun, which then affects the reading obtained. Number 4, the same toy gun and bullets are used to prevent any inconsistencies from occurring during the experiment which could affect the reading, since each toy gun has different firing strengths and each bullet has its own shape and size. Air resistance could affect each bullet differently based on the shape and surface of the bullet used.
So, based on the calculations that we have done in the report and in this presentation, we can conclude that the experimental value of initial velocity u is equal to 14 meter per second is less than the theoretical value of initial velocity u, which is 14.22 meter per second. The percentage of error of initial velocity u is 1.55%. So after getting the result, which is theoretical and experimental value, we can conclude our presentation. I would like to thank you all for listening to our presentation. That's all from our group. Thank you.